In this video, we're going to talk about some more problems and how to solve those with u substitution. So we're going to skip these in the middle. I'm going to come back to those later because they require a different u substitution than the ones below. So let's just look at a few of these. Let's start with 59. So in 59, we're trying to integrate x square root 3x squared plus 7 dx. This is going to work the same way as all the other ones. We really need to start by thinking about that square root as a 1/2 power. I'm just going to do some rearranging here. I think it makes it easier to see your u and du. So u is that inside function, 3x squared plus 7. Du is the derivative of that, which is 6x dx. So you can see this is what our u is, but we are missing the 6 here, and we need to compensate with a 1/6 out here. So now we're going to rewrite this as 1/6 times the integral of u to the 1/2 du. And when we integrate, we're going to add 1 to our exponent and divide by the new exponent. But that's the same thing as multiplying by the reciprocal. So I'm going to multiply by the reciprocal here. And then plus c. Now I like to clean this up. 2 and that 6 reduce. So we're going to have a 1/9 there. U to the 3/2 plus c. Finally, back substitute in. U was 3x squared plus 7. So there's our final answer. Let's do another one. Let's look at 62. So in 62, we have x times x squared plus 2 squared dx. Now I'm going to compare that one to 64, which is just x squared plus 2 quantity squared times dx. So we're going to start the same way. I'm going to rearrange. U is my inside function. Du is the derivative of that. Let's think about what we have. Here's our u. But from du, notice we're missing the 2 here. We can multiply it in as long as you compensate with a 1/2. So when we do the rewrite, we're integrating. Well, it's 1/2 times the integral of u squared du. And integrating that gives us 1/2 u to the 3rd over 3 plus c. Remember, those are multiplied together. And that's the same thing as 1/6 u cubed plus c. And then we're just going to back substitute in. So there's our final answer. But if we compare that to 64, notice the difference between these two problems is that you're missing the x here. Okay, well, that's kind of a big deal. If we started the same way, saying, well, what if u is x squared plus 2? Then du would be 2x dx. Notice we've got u, but notice we're missing a lot from du. We don't have an x in here, and we cannot multiply in an x. If we tried to do that, it changes the domain of the problem. We would put a 1/2 out here, but what would we do with that 1 over x? Okay, if we multiply it in, we went from a polynomial to now something that has conditions, right? Because x can't be 0, so that's a problem. And now we would still be back where we were before. You cannot pull an x outside of that integral because you have to integrate with respect to x. So putting the x out here would be a problem also. So what I'm saying is you can't do this. That's a no-no. So there's just a lot of problems there because we're missing that x. So what that means is that there's not a u substitution that we can do here. But in this case, we still could integrate. So we're integrating x squared plus 2 squared, which is really x squared plus 2 times x squared plus 2. And that is x to the 4th plus 4x squared plus 4. We could FOIL that out, and we could integrate each piece. Now, this doesn't always work, but in this case, it's an option for us. So there's our final answer. Okay, notice that's significantly different than what we had over here. So bottom line for that one, you can't multiply in x's, but you can multiply in missing numbers. Let's do another one. Let's look at 67. So this one could be written as a u substitution too, but with this one, we really need to rewrite it. I think it makes it easier to see. So that is the same thing as this. I pulled that ln of x to the 3rd power out, and that's times 1 over x times dx. So if we let u be ln of x, then du is 1 over x times dx. And then when we do our rewrite, we've got u cubed times du. That's our u. This is our du. And now it's easy to integrate. If we integrate that, we get u to the 4th over 4 plus c. So then when we do our back substitution, we're going to have 1/4 times ln of x to the 4th plus c. So there's our final answer. Let's do 68. We have e to the x over 1 plus e to the x dx. Now I want you to think about this one like this. We're going to pull that numerator out to the side. And that's a trick we've done a couple of times already. So let's try u being that denominator. So du in this case ends up being e to the x times dx. And you can see how we have everything we need here. So when we rewrite this, we have 1 over u times du, which is our ln rule. And in this case, we can drop the absolute value because 1 plus e to the x is always going to be a positive number. The absolute value just ensures positive. Let's look at 69. We've got 1 over x squared, e to the negative 1 over x dx. So I'm going to rewrite that. This way. So let's try letting u be that exponent, which we could rewrite as negative x to the negative 1. The derivative of that exponent, we would bring the exponent down, subtract 1 from the exponent. So that's actually going to be a positive x to the negative 2 dx, which is the same thing as 1 over x squared times dx. So you can see in this case, if we let that exponent be u, du ends up being all of this. So when we do our rewrite, we're integrating e to the u times du. Integrating e to the u gives us e to the u plus c. And then when we substitute in, u was negative 1 over x. Our final answer is e to the negative 1 over x plus c. And then let's do 70. So with this one, I'm going to do a rewrite also. Notice I've got an ln in here. I can think about this fraction this way as 1 over the ln of x times 1 over x dx. I know there's a relationship between ln of x and 1 over x. And we're going to use that relationship information. If I let u be ln of x, the derivative of u is 1 over x times dx. So let's do our substitution and let's see where that puts us. That bottom is u. All of this is du. So that gives us the integral of 1 over u times du, which is an ln rule. And then when we substitute back in, we have the ln of the absolute value of the ln of x plus c. I called this step rewrite. So that one I think is difficult to see without doing the u substitution. So you can see how the u substitutions and all the examples we have done has really made this much easier for us to be able to integrate.